All right, thanks a lot, Sean. Coming up next, we have Lee Howard. He's going to talk about the total cost of ownership of carrier-grade NAT, or, throw the acronyms out there, TCO of CGN. Thanks, Lee.
Thanks. Good morning. My name is Lee Howard. I work for Time Warner Cable. I'm the director of network technology there. And my job is to look at technologies that are 2 to 5 years away from being deployable in our network for good reasons. One of the interesting things that I get to do then is to, when we have technologies that are a couple of years away, we need to look at evaluate different options, different technologies, and decide which ones we want to use. So this is the kind of thing that I do. So a few years ago, we said, gee, IPv6 looks like it's 2 to 5 years away. It was. And so we ought to go start deploying IPv6. Naturally, we find ourselves here in Dallas, we find ourselves in the center of the widest deployment of IPv6 that Time Warner Cable has. We have deployed IPv6 fairly broadly across Texas. But while we were doing the evaluation, I said, I know that I want to do IPv6. I want to think about, are there any other alternatives? I think that carrier-grade NAT is not the best way to go, but is there a way that I can quantify that? Is there a way that I can say, here's why carrier-grade NAT is not the best idea for us? So let me stop for a second and say, I'm going to go ahead and skip to the last slide. The last slide says, go to www.asgard.org. My email address is there. And there's a link, the page there, it's called Documents. And on that page, I have this set of slides. I have a spreadsheet, so you can do your own numbers manipulation. And I have a 10-page white paper explaining the whole methodology that I use for everything I'm about to say with lots and lots of footnotes. So if you disagree with my numbers, where I got those numbers is all documented in that white paper. So go ahead and download it now if you want to, and we'll see what happens. So I've already said this is not exactly, I want to make clear, I am not presenting Time Warner Cable's strategy. This is not a strategy document. This is some analysis that I did. The idea was, we keep hearing that carrier-grade NAT is going to be expensive. Well, how expensive is it? Okay, so there are 3 costs that are going to go into that. There's how much capital you're going to spend. There's what's the OpEx to maintain the system. And then there's, we keep hearing that stuff breaks. What is it that breaks, and is there any way to quantify the cost of that breakage? And that's really where I started from. And then once I was able to do that kind of analysis, I then said, well, what can I do with that information? What else does that tell me? So here we go. So what does carrier-grade NAT cost? Well, I start with, you have to buy some hardware for the NAT device. And that may be a card and a router, or it may be a 1U device. And I sort of picked a round number of 10,000 users. So for a 10,000 user carrier-grade NAT, you need to buy a device. Now, this is the list for $70,000 is about an average of the list prices of several different NAT vendors that I talked to. So that's the number that I picked, and that's probably for a redundant pair, because even with 10,000 users seems like a failure domain of a significant size, but maybe an acceptable size depending on what kind of network you run. But you still probably want a redundant pair of whatever they are. You're going to have to do some kind of systems development for your logging systems, and that's going to be capitalizable. And then you're going to have to do some software development, your provisioning systems, your OSS, your discovery systems, whatever else it is that you have to do, there's going to be more work required. And it seems to me that for a smaller ISP that only has 10,000 users, it's going to take a few months. It's going to be about $10,000. For a very large ISP, it's going to scale up fairly linearly for the number of systems that have to be touched and developed in order to handle your carrier-grade NAT. So that's sort of where I got to that number. You can disagree with it. That's fine. This is sort of to get an order of magnitude for where we're going. And then it's how much is it going to cost to run this thing? Once you've bought a device, it's pretty much, it's the space, power, cooling, it's the people who are doing the cabling, it's the people who have to monitor the monitoring systems, all those sorts of things. So I sort of said $10,000 a year. Yeah, okay, so you can, maybe it's $7,000 a year, maybe it's $15,000 a year, but it's, somewhere in there. And again, you can go plug in your own numbers in the spreadsheet and figure out what it costs. This is the boring part. Where it gets interesting is when we say, all right, what breaks? Well, so I brought an intern into my lab a few years ago, and I said, here's a couple of different CGN vendors. Go test them with everything that we can think of, and tell me what breaks. And what we found was head-to-head gaming through Xbox breaks, and some PlayStation games were breaking. Peer-to-peer networking, you could do downloads, but you couldn't do uploads. Netflix, with some home gateways, wasn't reachable or was significantly degraded. And a few other sort of minor things were not going very well. I will say this is all documented in the IETF draft Donnelly NAT 444 impacts. Their testing was a little bit different than my testing, and sort of that's all in there. And I should point out that this document, NAT 444 impacts, has been updated, that subsequent testing shows that the Xbox 360 now does work through carrier-grade NAT. Okay, so let me get back to the ramifications of that. So here's what this table says. I said, well, how many users are there using an Xbox or a PlayStation or peer-to-peer networking? Dear Google, how many users are using these systems? And I came up with these numbers, all in the white paper where the footnotes come from. So out of 10,000 users, something like 2,100 of them will probably have an Xbox. Out of that 2,100, I don't know if all of them are doing head-to-head gaming. So let's say half use their Xbox to play games with somebody across town or across the country or some other ISP. All right, so half of users are potentially affected. If Xbox gaming breaks through carrier-grade NAT and half of users use the Xbox in a way that would break, okay, so that's how I get to that 1,050 number. Now, total swags. I have no defense for this number. How many customers, if you break their stuff, how many customers are going to get upset? Well, many of them are going to get upset. I just decided, let's say 25% are going to call tech support and say, what the hell's going on? And I just picked 25% are going to just cancel. Whether they call first and then cancel or just cancel silently, 25% are going to cancel if they're affected. Your numbers, you can pick any numbers you want to. The results certainly change. But here's the methodology that I went to. 50% are affected, 25% call, 25% cancel. Pick your own numbers. I've been told, when I've given this talk before, I've been told that I've erred on both the low side and the high side for both the number of support calls and the number of cancellations. So if anybody has a citation that I can point to saying, when you break customers, here's how many cancel, I would love to see that. That would really provide a lot of help for the analysis that I'm doing here. So then I go to the things that I know break, how many people I think will call, and I end up with the totals on the bottom there. Out of 10,000 users that you put behind carrier-grade NAT, some 6,700 will be potentially affected. Some 6,700 will have one of the systems that is potentially affected. Some 3,600 will be actually affected, plus or minus. You'll get 914 support calls, and you'll get 914 customers canceling. All right, that's actually pretty significant. All right, that's a real number. Maybe not a precise number, but it's a real number. Let's see what that means. So for each 10,000 users, let's say the cost of a tech support call is $20. Maybe it's $5 if you've offshored. Maybe it's $50. It depends on what tier they go to in your care center, and it depends on how long the call is. Let's say it's 20 for a round number. Okay, so that's going to cost you 914 calls times $20. It's going to cost you $18,000 in support costs. That's for 10,000 users that you've put behind carrier-grade NAT. You're paying $18,000 in support costs. That's not insignificant, but what really kills you is if your average revenue per user is $400 a year. By the way, I went to the annual reports for AT&T, Verizon, Comcast, and Time Warner Cable and said, what's your annual average revenue per user? ARPU. It was between them, among them, the average is $400. That's where I got that number. So if your ARPU is $400 a year, the total revenue lost to CGN is $400 times 914. 10,000 users behind carrier-grade NAT, it costs you $365,000. Wow. Okay? Total cost. Let's say you take it over 5 years. You're going to depreciate your CGN over 5 years. Okay, so you take your CapEx of $70,000, do a straight line depreciation, divide by 5. By the way, I'm actually a liberal arts major and a network engineer. I'm not a business guy. But here's what network engineers have to think about. So you depreciate your CapEx over 5 years, great, $18,000 a year. That's straight line. Your OpEx, flat $10,000 a year, we know that. Customer support calls, $18,000, I said that a minute ago. Well, you know, once you've done the carrier-grade NAT, they're either going to call or not call. You're not going to have a significant number of recurring calls for the same issues over time. So let's say that just happens, you know, day one, you deploy carrier-grade NAT, boom, all your calls come in, and then you're done with calls. And then you're losing the revenue. All right, I said on the last slide, $365,000 in lost revenue. That was per year. So multiply that out times 5 years, and it's actually costing you almost $2 million in lost revenue and CapEx and OpEx and customer support per 10,000 users. What does that mean? Well, here's my conclusion. By the way, the title slide was going to be animated, but I saved it in PDF, so we don't do animations. So here's the conclusion. CGN costs $2 million for every 10,000 users it's used for, or $40 per user per year. There you go. What do you think? No, don't tell me yet. That was just the first conclusion. So I think that's pretty shocking. I think it's a pretty radical conclusion, but I keep looking through how I'm doing this, and you can quibble with the numbers, but even if you take Xbox off of there and say, hey, it works perfectly, it's still $29. If you say, hey, if you break 1,000 customers, you're not going to lose 250. You're going to lose 500 customers. It's more like $55 per user per year. That's why you need to do your own math and take the spreadsheet and go and follow the white paper and figure it out for yourself. This order of magnitude seems pretty solid to me. Okay, so if CGN is going to cost you $40 per user per year, what does that mean? All right, would it be cheaper to just buy addresses? I mean, if a CGN is going to cost $40, and an IPv4 address we've seen on a couple of very public transfers have cost $11, $25, $12 per address, it's cheaper to buy addresses than it is to deploy CGN. Cool, good, I didn't want to deploy CGN anyway. Now, above $40, once the price of IPv4 addresses goes above $40 per address, then it's cheaper to deploy CGN. Holy cow. All right, is there a point where CGN becomes too expensive? If you say, all right, at between $12 and $40 buy addresses, at $40 and up, deploy CGN, is there an upper limit to the price of addresses where you wouldn't deploy CGN anymore? Well, I went back to the annual reports of those large ISPs, and on their ARPU of $400, they reported an average margin of 35%, profit margin. So 35% of $400 is $140 per user. Okay. So if you go and buy addresses in order to turn up new users, and you're spending $70 to buy an address, then your margin has just been cut in half, right? So if you spend $70, you're no longer making a $140 profit, you're making a $70 profit. If the price of that address is $71, you're now only making $69 in profit. In fact, at that point, it's more cost effective. You make a higher profit if you sell the address rather than turning up the customer. Wait, what did you just say? I'm going to say that again. If the price of an IPv4 address exceeds half of your profit margin, it's more profitable to sell the address than to turn up the customer, at least in the 1-year ROI. Now, I don't know what your CFO likes to do, but in a 1-year ROI, it's more profitable. Now, you could decide, well, gee, the average lifetime of a customer is actually 2 years. Okay, a 2-year ROI. Oh, maybe it's a 5-year ROI is what you want to look at. Okay, so then you have to go to what's half of the 5-year ROI. Okay, 5 years, customers worth $700. Could prices reach $350? I had a fun conversation with Jeff Houston yesterday, and he said, oh, yes. In fact, he said, oh, yes, I think something like that. I'm going to come back to more of what Jeff Houston has to say. So here's conclusion number 2, is this is advice to ISPs, between $0 and $40 buy addresses. Now maybe that's $29, do your own math, it's up to you. Between $0 and $40 buy addresses, between $40 and $70 deploy carrier-grade NAT. In excess of $70, deploy carrier-grade NAT because you want to keep your customers, but then you can actually crunch more customers onto carrier-grade NAT and sell off those IPv4 addresses. Holy cow. That surprised me an awful lot. I never thought that I would say you should buy addresses rather than deploy carrier-grade NAT, and I never thought I would say you should sell addresses. I'm not actually providing counsel to anybody here. That would be a very bad idea. But this is a very interesting thought experiment, isn't it? I'm guessing everybody's awake now. Maybe carrier-grade NAT isn't that bad. I never thought I'd hear myself say that, but let's take that as a thought experiment. Okay, so IPv6 is coming real soon now. That provides some relief, okay? Web and email actually work pretty well through carrier-grade NAT. I mean, you lose the granularity of being able to track a user if you're a content guy as they move among your content properties. You lose some of the law enforcement doesn't like it, so you lose some things. But from the user's perspective, they work. Okay, so who would you put behind your carrier-grade NAT? I've only been able to think of 2 ways to figure out who would be unaffected by carrier-grade NAT, who only uses things that don't break. One is to use deep packet inspection. Take one of the DPI vendors and go say, hey, I'm going to sniff all your traffic, and if you're using Xbox Live, then I'm not going to put you behind carrier-grade NAT. Well, that's pretty expensive and pretty intrusive, and it assumes that a user who's not doing something now is never going to do that, so it's pretty unreliable. So the only other way I've been able to figure out how to do this is to let customers sort themselves into using carrier-grade NAT and not using carrier-grade NAT. Why would a customer ever choose to use carrier-grade NAT? I can only think of one reason, and that's price. So how would prices be affected by the use of carrier-grade NAT in this 12 to 40, 40 to 70 kind of kind of era. All right, if carrier grade NAT costs $40 per year, and a native IPv4 address costs $12 to $70, then that's the increased cost to the ISP for deploying either a carrier grade NAT service or we buy you an IPv4 address service. So you end up having two tiers. You get your basic tier, carrier grade NAT, and your native IPv4 address tier, where you buy them an address. Now, so the prices will increase by $40 for the CGN customer and $12 to $70 for the purchase an IPv4 customer. The problem there is that's actually assuming that the ISP is just, so the ISP has two choices, really. The ISP can either absorb that cost into their margin. That sound you just heard was a collective gasp among all the CFOs in the country. Or you can pass that cost along to the customer. ISPs in general are for-profit entities and don't just pass things along at cost, right? We already said there's a 35% margin, so the change in pricing that I can predict is $400 per year ARPU means $33 a month on average for broadband internet service. So if you increase for the carrier grade NAT at $40 per year, you're going to increase the cost by 13% for a decreased service. In other words, from the internet we know today, add carrier grade NAT, and for that privilege, you get to pay 13% more as a consumer. If, as a consumer, you don't want carrier grade NAT, well, so as an ISP, you can choose where you're going to price that service. You're probably going to price it at the higher end of the address market, right? You're not going to charge $12 to buy an address because your cost per address may increase up to $70, we said. So if they increase up to $70, that's the line where you're going to set your pricing. So that $70 becomes 21% increase in order to have the same service that you have now. Wow. Or, of course, you can just cut margins. Gasp. I'm not done yet. Oh, so, okay. There's one more thing I had to bring in here. So this assumes, and this is back to my Jeff Houston conversation. So this assumes that it's all cost, right? That ISPs just deploy carrier grade NAT and they suck up the cost and either just absorb it or pass it along to consumers. Jeff Houston bumped into him at lunch yesterday, and he said, "You're thinking about this all wrong. Carrier grade NAT can be a profit center. If you're running carrier grade NAT, then there are content guys who would, if you're running carrier grade NAT, there are content guys who would pay through the nose to be inside your NAT. There's a premium CDN service to be on your net 10 space. And that's because then they can see the actual addresses for all those users and track them as they're going to the various properties. So in fact, you can make money by deploying carrier grade NAT. Now this was at lunch yesterday, so I haven't been able to build this into the model and see what happens there. And then he said, you're assuming that you're only going to multiplex 10 or 100 or 1,000 users per IPv4 address. Jeff has told me that he's actually seeing cases where you have 5-tuple natting. Meaning, if you have 1,000 users going to 1,000 different websites, they can share the same outside address and port number because you only need that same outside address and port number for each of the different instances. When the response comes back in, you've mapped that website, that website to the same internal user. So if you do a 5-tuple carrier grade natting, then you actually, of course, you've got much larger logs, but then you can actually do much greater compression of users to IPv4 address. That certainly helps you want to go sell off the rest of your IPv4 addresses. Now, then he says, if you're doing that, you now have the user's address and the website that they go to for every single place that your customers go online. This doesn't sound like something that I really want to do. But Jeff's argument would be, that's really valuable information. If you put a timestamp on that, somebody will pay you dearly for the ability to say, show me for that user, I can now mine this data for that user, every website they've been to, in what order. And after they went to this website, what did they click on next? And then where did they go? And before they came here, where did they come from? That's really valuable information. Now, again, this is only 20 hours old. I haven't really had time to think about this, but I woke up in the middle of the night and I said, all right, so if a frequent flyer program will give you something like a 1/10 of a cent in rewards for every $100 you spend, that's probably about the value. Actually, this is Jeff again. That's probably about the value of that information. So what if users spend online? Here you go. Here's the value of the information. If a user spends $10,000 a year online, then somebody who's going to buy this information will give you $10 for each user's data in order to see where they're going. All right, $10 per user. Now you can need some kind of massive big data system in order to log those 5 tuples for every single flow that's created on your network. That's an awful lot of data. The bandwidth alone is huge. It seems like it's about a break-even proposition just in my 3 o'clock in the morning kind of ramblings. I'm not sure, and if it's about break-even at 3 o'clock in the morning, there may be some more interesting research to be done there. So this is conclusion 3.5. And this is really scary to me because I haven't even thought of this. And I told Jeff, you're a very bad man. Evil, yes, says the guy from Google. So how far can we go? I've already gone pretty far in this thought experiment. So how far can we go? Okay, so as an ISP runs out of IPv4 addresses, obviously it's got to conserve those addresses for its most profitable customers. Now, I already said you can make customers, you can charge more for a native IPv4 address, and that becomes your more profitable customer. The rational ISP is going to say, hey, CGN is really expensive, buying address is really expensive. As I'm doing these kinds of services, I have to roll out IPv6, just so there's an exit strategy and I can reduce my costs back out of the carrier-grade NAT or buying IPv4 scenarios. But you can't really change a customer's service, either to add the CGN option or the buying you an IPv4 address option until contract renewal time, right? So, okay, contract renewal comes up and you say, hey, customer, your contract is set to renew. We have new service tiers, and you get to choose whether you want basic or advanced, or standard, I guess I said here, standard or advanced. Again, the CGN or the native IPv4 solution. But, hey, congratulations, what an excellent choice you've made. We'll increase your bill to reflect that, and here's a shiny new cable modem or DSL modem or whatever CPE you choose that supports IPv6. Fantastic. Now, wait a minute, okay. So if at contract renewal time, an ISP starts to change its services to add that in, then again, I could not find any sources online telling me the average lifetime, the average contract term for a residential customer. So my conclusion is, one, whatever the value of contract term is, after an ISP runs out of IPv4, everyone at that ISP will have IPv6. So how fast is that really? Well, okay. When Aaron runs out, Jeff currently projects sometime middle of 2013 in the Aaron region. He's got that probability curve, so you don't know whether it's going to be April or August or December. But let's say it's middle of 2013. And let's say an average contract is, I don't know, a year, 2 years, somewhere in the middle, 18 months. The prudent ISP is going to make sure that all of its customers have access to IPv6 by the end of 2014. Hey, I actually came up with a conclusion I kind of like. I actually concluded something here that says, look, IPv6 is not only coming, it's not only going to be here soon. I can pick a date, and a fairly arbitrary date, but I can say, look, if ISPs are prudent and rational, if ISPs are prudent and rational, then they will be deploying IPv6 very rapidly over the next couple of years as they approach runout. So, in summary, here are my 4 conclusions. Carrier-grade NAT costs $2 million over the course of 5 years for every 10,000 users you apply it for. And that divides out to $40 per user per year. Again, if you take out Xbox, it's more like $29. By the way, if you add in the cost of buying addresses to put on the outside of your carrier-grade NAT, depending on the cost of the address, it's another 40 cents to $20 or something. So again, right back up there. So given that the cost of carrier-grade NAT is $40, if the price of IPv4 addresses is less than $40, buy addresses, don't deploy carrier-grade NAT. If the price of IPv4 addresses is more than $40, deploy carrier-grade NAT. Another thing I just remembered that I wanted to mention, Ben Edelman, Harvard economist, has a paper talking about the price curves of IPv4 addresses. And he says, it's a very interesting thing in economics that when you set the price for a property, when you set the price for something, the future value of that object, that thing being sold, is built into the price, right? You pay based on what you think it's going to be worth. So his assertion, if I understand him correctly, he's a Harvard economist, I'm an English major. If I understand him correctly, his assertion is that the price of IPv4 addresses will be at its peak right before Aaron runs out. Because after Aaron runs out, IPv4 addresses will never get more valuable than they currently are. and the future value is built into the price. I'm not sure, I can't handle the math that he does there, but it's a pretty interesting assertion. Okay, so between $40 and $70, deploy carrier-grade NAT. Above $70, it's more profitable to sell the address than it is to use that address to turn up a customer. We can look at those prices and say prices would likely increase. If ISPs are incurring these costs, they're going to add those prices, they're going to pass those costs with profit margin along to their users at 13 or 21% increases for the consumer. And then the rational ISP will have 100% of their customers on IPv6 by the end of 2014. Draw your own conclusions. I provided a methodology. The numbers are very interesting here. I came up with, this is very surprising conclusions for me, but that's why I provided the site here, so you can see my methodology, my sources for the numbers that I have sources for. I very clearly state I don't have sources for some of these numbers. I made assumptions. And there's also a spreadsheet there that says plug in your own numbers, do the math, and here's what you could come up with. I have about 4 minutes left, maybe a little bit longer before the break. I would be delighted to take questions and comments. I can even catch fruit. Kathy was first.
Hi, I'm Kathy Aronson. I feel like I just watched my professor in my math class prove that 2 equals 1.
Yes.
And wow, that was a flashback. But the one assumption that I can't help but think is being overlooked is that you're assuming that when everyone goes to V6 that everything's going to work and they're not going to disconnect from you and go to a provider that does V4 because V6 maybe doesn't get them where they want to go.
Right. Well, of course IPv6 works. That is take as given that IPv6 works. Now, actually, one of the things that I do say in the paper is that although ISPs would, I'm sure, love to be able to pass those costs on along to their customers, in a competitive environment, you may not be able to do that because people can go down the street to the next ISP and turn up service with them. So yeah, you may have to, and that's a pretty scary idea. I think the person at the back mic, I can't quite see, was next.
Ben Edelman, Harvard Business School, and
hi,
Aaron. Thanks for the plug of that paper. To folks wondering about the seemingly counterintuitive result that prices should be always decreasing, that's a result that turns on the fact that everyone knows everything and no one is ever surprised. The kind of assumption that economists love to make.
Right.
If you knew exactly how quickly IPv6 could be implemented and you knew how much V4 was out there, what the price trajectory would be, then there would be no reason for prices ever to increase for V4 because the asset would only be getting less valuable. If there can be negative supply shocks, positive demand shocks, the economy grows faster, V6 doesn't work, then that conclusion wouldn't follow. But I wanted to just weigh in on one other aspect of the slides. Quite thought-provoking and, of course, the best analysis of its kind. But what we saw this morning was all analysis of demand. What we didn't hear much about was supply. And so if we were to price water by thinking about what a thirsty man might be willing to pay in the desert, you could get a very funny estimate of what water is going to cost if all you did was think about what you'd be able to pay, what you'd be willing to pay if you were thirsty in the desert. In fact, water isn't priced that way because there's a lot of it. There's a lot of supply of water, and so the price of water is pretty close to zero. How about V4? There's V4 out there. There are people who can vacate their V4, pushing the price back down, and a lot of folks who might do pretty well to sell at the kinds of prices that we saw on the board. So I wouldn't be too quick to assume that the market clearing price will be in the sorts of ranges just discussed. If it got to those ranges, then I think we know what we should do as ISPs, but that doesn't mean we'll actually be at those numbers.
So it's your assertion that 2 does not equal 1?
Not today.
So actually, that's an excellent point, and it is something that we talked about when I was working on this. One of the things so it may be that that 11, especially that floor that I provided of $11, $12 is high based on the fact, and I do say this in the paper, it may be high based on the fact that those were purchased in bankruptcy, some of the cases that John was talking about. And there may be special properties from addresses purchased in bankruptcy. It may be that because they were extra large blocks, that they're more valuable than certain smaller blocks may be. There are lots of factors go into the actual pricing there. I did, in fact, hear purely hearsay last week when I was in Europe that there are people in Europe looking to sell addresses or offering addresses for, interestingly, this again, purely hearsay, I don't want to be sort of cited for this, that they were offering addresses at $3 US per IPv4 address for ARIN region addresses and $4 for APNIC region addresses. I was unable to track down a source for that, but isn't that interesting? Yeah. Thanks, Ben. Oh, yes, front mic.
Jeff Houston.
Would you like to do
I
an
can't do
Ameri-
an American accent,
Oh,
I'm
come
sorry.
on.
You know, I too was thinking last night about monetizing CGNs, and I was wrong. Google's a wonderful thing, and it tells you the price of a frequent flyer point, which is 0.74 cents in the dollar. My supermarket pays that price to track my purchases, 0.74 cents in the dollar. So now my $10,000 online spend, if the CGN tracks everything I do, every ad I click, everywhere I go, the order at which I do it and the time at which I do it, my spend of $10,000 equals $740 of value in tracking in today's market. The more I spend, the more it's worth. Put that into your spreadsheet and see how far you get. All of a sudden, CGNs are an amazing, interesting source of revenue for the deployer because it allows the carrier an insight into content that the 20 bytes of IP header never gave them. And that monetization is worth way more than the capital cost of the CGN or its OPEX, as you yourself showed. Once they get into that mold and monetize it, what's it going to cost to get them to get rid of it? Thank you.
Yeah, as I said, you are a very bad man. I'm curious to hear what Bobby Flame has to say about this topic too. Bobby's with the FBI, and they have interesting thoughts about the tracking of IP addresses. Yeah, that's... Oh, and I wonder if then, hey, that kind of money might have a chilling effect on the internet economy, if people would be nervous about being tracked that well. Oh, Jeff has a response to that.
Okay, hands up everyone with a frequent flyer card. Yeah, we're all really nervous about it.
Yep. Anybody here use Google or Facebook? Right, okay. I think front mic was still next.
Andrew Dole, Cascadio. I think one of the things that could be added to this thought process is the cost of deploying v6, the cost of breakage, and coming up with a three-tiered stool rather than a two-tiered stool that you have here. And that might bring some interesting conclusions with regard to the break point between deploying v6 cost versus deploying CGN versus the buying. And that's something that I started thinking about 2 months ago, but never got anywhere because regular work caught me up with regular stuff.
I do have a section in the paper about the cost of deploying IPv6. It is fairly hard to calculate because it does vary so much by what kind of organization you are. I think my assertion is that if you have a 5-year deployment schedule, get a time machine. If you have a 5-year deployment schedule and you have a 5-year depreciation cycle, then all of your non-v6 capable hardware will depreciate over the course of your v6 deployment, and your CapEx is nothing. You still have OpEx. But your OpEx is over 5 years. It's whatever your normal, as you go touch all of your internal coded systems, it's, add in some time to code v6 as well as whatever you were going to add in for new features anyway. And it's, 5 or 10%, so it's maybe not that big a deal. If you compress the schedule, then you may have some hardware that isn't fully depreciated that you have to replace before it's fully depreciated. On the other hand, most hardware these days actually does, depending on, again, what you're talking about, does support v6.
So I think the hardware you're missing is the CPE hardware there.
That's true.
And the costs associated with breakage when new CPE comes in and v6 doesn't work as expected when devices try to use it. So those three things are...
Do you need me to cap the mics here? We're doing for time. Well, okay. We'll go ahead and... front mic, I think, was next.
No, he was...
Okay, back mic then. Sorry.
Matthew Moylecroft from Amazon. I'll mark you down for your Australian accent impression. That was pretty bad. Depending on your economy's view on legal interception and so on, if you're running carrier-grade NAT, you may have to be logging the data about the 5-tuple anyway.
Right.
So, in fact, the break-even thing might, in fact, be a way of paying for that. I don't want to reinforce Jeff's views. That feels dirty, but,
That's absolutely true. If you're required by law to do it anyway, then you might as well make a buck off of it. Yeah.
Hi, Patrick Gilmore Akamai. As much as I shudder to disagree with such a esteemed personage as Jeff, I'd like to ask everybody here, who put your frequent flyer card in when you bought your NANOG registration? I didn't think so. Everybody has a frequent flyer card. I think I have more miles than everybody in the room. The point is, things are not actually worth 0.74 cents each time. You spend a lot of money that no one ever gives you any points on. Nobody wants to. Your corner store doesn't care about frequent flyer. They don't want to know. So that $10,000 you spend online, it's very well tracked, but not every single store wants to know every single thing. So that's actually a false equation. You can't actually say, well, I spent $1, therefore I get exactly that much money. So you have to figure out how much less you're going to get. You've also talked about things like CDNs. I work for a small company called Akamai. I don't remember telling anybody that we're going to pay a premium for getting behind this CGN. I've never told a single person that. And I've talked to a lot of you in this room about CGN. So there's many assumptions that came out about CGNs being a profit margin that don't actually hold. Now, that doesn't mean that you're not going to get any money out of tracking people's usage. Lots of companies do that. Even Akamai has a product that helps you figure out where to target advertising. So that's actually a useful thing. But you can't assume that $10,000 equals $740, because that is not even going to come close to the correct answer. And you can't assume that all CDNs are going to pay to get behind the CGN, and you can't assume lots of other things. So you've got a lot of assumptions on one end, and you've got a bad man telling you those assumptions are wrong, and I'm telling you that not all of his assumptions are correct either. No, right. So in general, we have no frickin' clue.
Right.
But that's okay, because that's how we've run the internet for the last 40 years, and it seemed to work out.
I'm actually greatly reassured to hear your pushback on the stuff. Again, that's the stuff that I haven't really been able to think through very long. So 3 o'clock in the morning, that's not my best time.
Lee?
Yes.
I have 2 quick questions. First one is, do the ISPs think that the consumer won't be able to make a choice between a dedicated IPv4 address and a NAT? So if they don't want to be tracked, or they don't, and it's not just the current users, but people who are making a decision where they might use Xbox or something else. So it seems like it's just assumed to be the way it is. And then the second thing is, why do you believe that by the end of 2014, the transition will be complete?
Those are very interesting questions. Let me start with, I would certainly not presume to speak on behalf of ISPs. Even one that I work for, I would not just presume to speak on behalf of them. So no, that's actually a really interesting point, is consumers might decide to choose the CGN for privacy reasons, not just because it's a cheaper alternative. I certainly haven't done any breakdown on what the mix in uptake would be, so that's an interesting idea. As far as deployment of V6, that's, so what I said is ISPs behaving rationally and according to sort of their own contract renewal time would have it deployed to customers, but I did not say that consumer electronics would be ready or that all websites or content would be ready. I don't believe that. The biggest problem right now, the biggest thing I think holding back the deployment of IPv6 is that consumer electronics aren't ready. And even when substantially all consumer electronics support IPv6, it will take years for the ones that don't to age out of the network. There may be some value of households that have only V6 capable equipment that could live on a V6 only service if there's enough content that's on V6, but I don't think we have that density either. So exactly where and how that happens, I would love to hear more ideas for advancing deployment.
Very neat study.
Yes, more work needs to be done. Middle.
Hi, Seiichi Kamara, NEC Big Club. This was really nice. I kind of did the math myself about a year ago, not as good as this one. So I think I'm going to go back and do my math again. But when I did the calculations for I work in an ISP. I did the calculations, I came up with the number of year 2015, I had to finish deploying V6 100% or I'm going to start losing money. So I guess that's a pretty close number to the 2014 that you came up with. The one figure that I couldn't really come up with was the cost of the innovation opportunities that we would lose with CGN. I could not make that into numbers, so I would be really interested if there was a way to, sort of make that a number, and so we could show that to our executives.
That's, I have never been able to figure out a good way to quantify opportunity cost, either in terms of innovation or in terms of, as you're deploying CGN or IPv6 even, if you don't have if you haven't started years ago and you're still in the process of figuring out how you're going to do it, you're going to have to stop work on other products while you roll out V6. I wish you'd started earlier.
Yeah, I agree. Thanks.
Folks, we have time for one more question. Thanks.
Leif Sawyer, GCI, Alaska. MSO ISP, not speaking on behalf of the ISP, but as I suppose any ISP might do. There's another tier that you've forgotten, I think, which is those users wanting a static IP to always have that IP address available on the internet. And you can provide that both at the CGN side, right, where you can always have a static translation, or you can also have a static natural IP. So those are two more areas where you can monetize. And I think that might even touch on the other gentleman's point about...
Interesting, okay.
Remote participant. Derek Reese works for an ISP and made a comment that CGN makes him nervous about customer experience. He knows for a fact his company is not going to charge a premium for a subscriber behind CGN.
Okay, I hope that was as much fun. Good. I hope that was as much fun for everybody else as that was for me. Really, I love taking thoughts as far as they can go and seeing where I can end up. So thank you all very much.